Lecture number 3 provided more discussion on the relative merits of using a tax or cap auction and trade to raise the prices of greenhouse gas emissions. Regardless of the instrument, Daly argues that the higher resource prices resulting from limited depletion would have the dynamic effect of inducing resource-saving technology and a shift to greater dependence on solar energy and renewable resources. Although the terminology of circular economy had not been developed in the 1970s, I find it likely that Daly would have advocated for its necessity. Our reading list of this year also included Geng, Sarkis, and Bleiswitz their call to globalize the circular economy by setting up a global database on best practices, platforms to share knowledge, and develop internationally standardized key performance indicators. There is an urgent need to increase recycling of material flows. As Geng et al. Write, it takes a ton of metal, silicon, and plastic to produce a laptop weighing a few kilograms. Just 6% of materials are recycled. This is surprisingly little given the potential savings. For this 6% estimate, Geng et al. Refer to Haas et al. 2015 their analysis of how circular the global economy was in 2005. Which included the following Sankey diagram of material flows, where the numbers are in gigatons per year and the width of the flows equals their relative size. These aggregated Sankey diagrams of material cycles, such as the global and Chinese aluminium cycle in 2016 presented in Geng et al. And on this slide, could prove a useful policy tool. These diagrams give some idea of how much room we have for development without further growth. Geng et al. Also write that circular economy concepts are more often celebrated than critiqued. In my opinion, we should indeed celebrate circular economy as a move in the right direction. However, let me also present a critique. That is, the circular economy is more like a necessary condition for sustainability, but it does not give any guidance for the tolerable size of material flows in the circular economy. Or in other words, perhaps we should first learn how to close the loop before we allow it to expand further. And while steady-state economics remains rather abstract, the focus on zero growth is more clear than the concept of sustainable development, for which it seems that everyone can make up their definition now. More recently, the idea of doughnut economics has been gaining popularity. This model does take the idea of ecological boundaries more seriously, as it starts from the planetary boundaries which we discussed in the first lecture, that provide an ecological ceiling for economic activity. The doughnut model adds to this an inner social foundation, which expresses the minimum desired socio-economic conditions and personal liberties necessary to provide for a happy life. Let us listen to Rayward her explanation of the model and see how it informs Amsterdam policy making in the following clip from BBC Real.